morning, dear students. Today we are going to demonstrate the fourth experiment, estimation of acids in acid mixture conductometrically. So this is the conductometer. So today we are going to estimate the amount of acids in an acid mixture. That means we are taking an acid mixture which is containing a strong acid and weak acid. The strong acid used is HCl and the weak acid used is acetic acid. So we have mixed both the acids, acetic acid and HCl, in a beaker. And now from this acid mixture, now we have to do the estimation of acids separately, amount of acids present in this acid mixture conductometrically. Okay, now you have to know when I say conductometrically, you have to understand what is conductance. Conductance is nothing but the reciprocal of resistance. Okay, there are three types of conductances mainly. One is specific conductance, molar conductance and equivalent conductance. But in this experiment, we are measuring the specific conductance. You have to know what is specific conductance. If you see the instrument, the conductometer is connected to a conductivity cell. This is called conductivity cell. The electrode used is nothing but called as conductivity cell. This conductivity cell consists of inside two platinum electrodes which are having 1 centimeter square area and kept at 1 centimeter apart. That means they have fixed having 1 centimeter square area and having 1 centimeter apart distance. That's why the type of conductance what we are going to measure is called as specific conductance. Okay, this is the conductometer connected to a conductivity cell, consists of two platinum electrodes inside, kept at 1 centimeter apart, and we are going to measure the conductance of the solution. The conductance is nothing but the reciprocal of resistance. In the units are Mohs inverse and centimeter inverse. Suppose now when you wanted to do this experiment again, we have to first wash the conductivity cell properly with the distilled water, and we have to take the beaker containing acid mixture and you have to dip the conductivity cell. Okay, and this is the acid mixture having both acetic acid as well as HCl. And now we have to understand that the conductance of the solution, it depends on three factors. It depends on the number of ions present in the solution, it depends on the mobility of the ions present in the solution, and depends on the size of the ion. Because if you take H plus ion, where the size of H plus ion is very small, so because of its small size, the mobility of the ion will be more, and if it is a strong acid, there will be more number of H plus ions. That's why the conductance depends on the size of the ion, the mobility of the ion, and the number of ions present in the solution. Okay, now I have dipped the conductivity cell in the acid mixture. So as soon as dipping the conductivity cell, it is showing the conductance of 28. That means now the conductance whatever we have observed, it is due to the conductance of H plus ions, because first the strong acid which is present here will be completely ionized because it is a strong acid. So the conductance is due to the presence of more number of H plus ions which are dissociated from strong acid. Okay, now we have to note down, without adding the sodium hydroxide from the burette, we are noting down the conductance of the solution here, ohm inverse, centimeter inverse, it's a 28. Okay, now again I am taking a micro burette of 25 ml capacity and filled with one normal sodium hydroxide solution, and fill the burette completely up to the mark, and see that there should not be any bubbles in the nozzle, and see that the nozzle should be inside the beaker. Okay, now we are using one normal sodium hydroxide in the burette and taking acid mixture in the beaker. So again this reaction is a neutralization reaction, acid-base reaction. It's a neutralization reaction. So out of the two acids which are taken here, the strong acid and weak acid, first the neutralization of strong acid occurs because it is a strong and it is completely dissociated. So the neutralization of H plus ions by the OH minus ions occur. Then after the completion of the neutralization of strong acid, then the weak acid will be neutralized later. Okay, now we will start the experiment by adding 0.5 normal of sodium hydroxide from the burette. 0.5 normal. So when I am adding 0.5 normal of sodium hydroxide from the burette, the H plus ions of the strong acid are neutralized by the base. So that's why the H plus ion concentration is decreasing here. The number of ions are less here. That's why when the number of ions are less here, you will observe a decrease in the conductance. So the conductance value decreases from 28 to 25. That's why I told you it depends on the number of ions present in the solution. The number of ions are decreasing because the H plus ions are getting neutralized by the OH minus ions of the base. Okay. Now I am adding again 0.5 ml of sodium hydroxide from the burette. Again I am shaking the solution. Again the neutralization reaction occurs. So the H plus ion concentration is decreasing, the number is decreasing. Now the conductance of the solution is 21. Now again I am adding 0.5 ml of sodium hydroxide, that is from 1 to 1.5. Again after adding, I am shaking the solution to complete the reaction process. And noting down, again now the conductance of the solution is 80. It's decreasing. Okay. Now again I am adding 0.5 ml, that is from 1.5 to 2 ml of sodium hydroxide from the burette. Again I am noting down. So suddenly it is further decreasing because here the neutralization of strong acid is occurring, not the weak acid. Now it is 50. Again I am adding 0.5 ml, that is from 2 to 2.5 ml I am adding sodium hydroxide. Here now the strong acid is almost completely neutralized. That's why there is no much change in the conductance we are observing here. Now the conductance is 12, earlier it is 15, now it is 12. So there is no much change. Now I am adding again another 0.5 ml, that is from 2.5 to 3 ml of sodium hydroxide from the burette. Again shaking the solution. Don't forget that we have to shake, otherwise the reaction will not occur. Now the conductance is decreased from 12 to 9. It's almost the neutralization point of strong acid is reached. Now I am adding from 3 to 3.5. Again I am shaking the solution for the reaction to occur. And now the neutralization of weak acid started. So as it is a weak acid which partially ionizes, so there are less number of H plus ions are present. So because of less number of H plus ions, the conductance will be less. Now it is 7. Now I am adding from 3.5 to 4. So now the neutralization of strong acid is over. Now the neutralization of weak acid is going on now. After addition of 0.5 ml of sodium hydroxide, again I am shaking the solution well and noting down. Now again it's constant, there is no change, again it's only 0.7. That means now the weak acid neutralization is also getting over. So now I am adding from 4 to 4.5. No change in the conductance. Now you can observe the conductance starts increasing. Until now the conductance is decreased. Try to understand here. Until now the conductance is decreased from 28 to 7 because first the neutralization of strong acid occurred. So H plus ion concentration is decreasing. So the conductance is decreasing. So after the neutralization of strong acid, weak acid neutralization occurred because of less number of H plus ions released from acetic acid. So the concentration is less, number of ions are less, so the conductance is less here. Now complete neutralization of strong acid and weak acid is over, so there are no more H plus ions in the solution. So now, but from the burette we are adding OH minus ions into the solution. So now whatever the conductance we are observing now here, it is due to the mobility of OH minus ions present in the solution. So now it is 0.8. So it started increasing the conductance now. Please think, many of the students will think that the conductance has to decrease continuously, but it will not be like that, because the conductance depends on the size of the ions and the mobility of ions present in the solution. That's why whatever now the conductance is increasing, that conductance is due to the OH minus ions which we are adding from the burette. Because the OH is not getting neutralized because there are no more H plus ions here. Now the conductance is 8. Again I am adding 0.5 ml, that is from 5 to 5.5. The concentration of OH minus ions, but because of the size of the OH minus ion compared to H plus ion, it is bigger. So because of its bigger size, the mobility of OH minus ions will be less. Because of less mobility, the conductance will be less compared to H plus ions. Now the conductance is 0.9. It's increasing, but increase is less because of the size of OH minus ions. Now I am adding from 5.5 to 6 ml. So it is 0.9. Again I am adding 0.5 ml, 8 to 8.5. The conductance started increasing. Now the conductance is 10. Again I am adding from 6.5 to 7 ml of sodium hydroxide from the burette. Again shaking the solution. Please remember, after addition of each 0.5 ml, we have to shake the solution well. Now the conductance is 11. I am adding again from 7 to 7.5. Slowly it is increasing, not drastically, because of OH minus ion, which is a bigger in size. Now it is 12. Again I am adding 0.5 ml from 7.5 to 8. Again shaking the solution. Because of more number of OH minus ions, there is an increase in the conductance. Now the conductance is increased from 12 to 14. Now adding from 8 to 8.5. Now the conductance is reached to 15. Now I am again adding from 8.5 to 9 ml of sodium hydroxide from the burette. Again shaking the solution. Now it is 17. I am adding from 9 to 9.5. Now the conductance of the solution is 90. The last reading from 9.5 to 10 ml, because we have to add up to 10 ml, because we need some readings to get an accurate graph. So we have to add up to 10 ml of sodium hydroxide from the burette. Okay, that means 10 ml means 20 readings we have to take. So now the conductance of the solution is 20. Okay, we have completed noting down the neutralization point readings. Okay, now again I am repeating the overall experiment. We are estimating today amount of acids present in acid mixture conductometrically using conductometer connected to a conductivity cell containing 2 platinum electrodes kept at 1 centimeter apart. So we are measuring the specific conductance. Conductance is nothing but the reciprocal of resistance, and as we are taking an acid from the burette, we are adding sodium hydroxide, so it is a type of neutralization reaction. Okay, thank you.